Okay, I want to talk a little bit about the ESP32. And again, there's a bunch of different variants of the ESP32. A number of them are dual core chips, although you can get some. There's an ESP32S series, which are trying to compete more closely in price with ESP8266s, and they're single core. We have the version that we are using is the Wi-Fi LoRa 32 from Heltec. It has a little OLED screen. More specifically, we're using the version 2.1. And if we look at some of the different info here, hopefully, it shows it with a board with a little case or whatever, although I've never seen on some other than directly from this site. Usually we get them in kind of this kind of fashion here. That's the one we have. And it should have a little V2. They doubled the RAM or the flash available actually, and they changed where a couple of the pins go as far as that goes. But more or less um, it's the same. But if you went looking for a pin out, make sure it says the V2 because there are a couple of pins that are changed on it. And so if I look there, I should have a tech specs. So as far as the chip, we have our typical ESP32. So what that gives us is it gives us Wi-Fi, and so 2.4 gigahertz, so 802.11. We have Bluetooth. Bluetooth, it says Bluetooth 4.2. So it'll do traditional Bluetooth and Bluetooth LE. And so the traditional Bluetooth, if I was to make a serial communications interface and do pairing and all of that. Bluetooth LE is a lighter weight as far as battery use and is good for monitoring and sensors and for instance, heart rate sensors or temperature sensors or just broadcasting and having beacons around a mall and do mapping and that kind of thing. And so you can do that nicely with BLE, different from the protocol entirely from your standard Bluetooth. And then we also have our LoRa, and what our LoRa is made up of there is in addition in the Heltec board, there's also an SX1276 chip, and that's this LoRa communications receiver. A couple other things that are on there as part of just being your ESP32, we have serial port interfaces. We have SPI and I2C, I2S, 12-bit ADD, one of them, and then it also has a DAC and a bunch of GPIOs that are available as well. There's also what do they call it? SH1.25. There's a little connector on the side, and you can put a lithium-ion battery. So if you want to be able to plug in a battery, when you plug in USB, it charges up the battery. Then you can unplug it and go stick it somewhere and put it into low power and put it to sleep for most of the time, hopefully, and then be able to wake up and just do some LoRa communications. So that's on Heltec's site. You can get a Heltec Wi-Fi board that looks kind of like this just by itself, but it doesn't have that SX1276 chip, and that's the one that's going to allow us to do this 900 megahertz long-range communications. And so I want to talk a little bit about that. So that's I've put this whole page up for everybody to have a look at, and then we are going to use in the Arduino interface. There's a number of different ones. Again, we can use Espressive's own development environment, their software development environment, or you can use the Arduino interface, and you use the board manager to have it load a JSON file, which basically tells it where to go find the whole software development kit and all the board support packages and things. And so it's off this Arduino reference library that tells you about the Heltec ESP32 dev boards. You can use the Arduino interface for the ESP8266. Search ESP8266 Arduino, find the board support JSON file for that one. You can do it for the ESP32s. You can do it for your ARM board, the STM32F407. If you go STM32 Arduino, there's a whole bunch of samples and things using your Arduino interface instead of the Cube IDE that we did. And so you can do that kind of thing as well. Also with boards like, just a little digression, also the boards like the ESP8266, more so the ESP32 and any of the ARM boards, you can also put a Python interpreter on it and be coding in Python. And so it will give you a serial interface, and then you just type Python 3 code and it will respond to that. And so you can do that kind of thing. One of the things that's on board that reason that we have this board is to talk a little bit about the LoRa interface. And so this is off on Wikipedia, and I just want to go over to the Wikipedia site to talk about this. And it says LoRa stands for our long range, and it's a proprietary low power wide area network modulation technique based on spread spectrum derived from something known as chirp spread spectrum. And it was developed in France, and it was acquired by Semtech. So Semtech is the licensee of the or owner of the LoRa protocol, and it's a founding member of the LoRa Alliance and its patented technology. So there is the LoRa Physical and the SX1276, and you can just go buy an SX1276. It's pretty much the same or almost more expensive for you to buy an SX1276 as it is to get the LoRa, the Heltec board with the OLED screen, the ESP32, and the SX1276, at least in the quantities that we look at for class here. So that's why I get one of those, because I could have said, hey, on the ARM chip, we're going to interface LoRa, but you get the whole ESP32 to play with, and you don't have to look at the LoRa, or you can look at the LoRa for the same kind of thing. So this is a picture. If you were to go buy the SX1276, you can buy a little board like this, a little chip on it, a bunch of interfacing over to your antenna, and you're sending data out. Now, there's different frequency ranges in LoRa depending on where you are, and it says LoRa uses license-free sub-gigahertz. So in the EU, we're 433 megahertz, that kind of a range, and that's the unlicensed bands in Europe. And then in the EU, you're 863 to 870 megahertz. In Australia, it's 915 to 928. And in North America and in Canada, it's 902 to 928. And so we're in that kind of band. So it's an unlicensed band, and we'll put things in there. So again, 900 megahertz that we're going to look at. And so the technology covers the physical layer, while other technologies and protocols such as LoRaWAN cover the upper layers. And similar to when we're talking about networking, and you talk about the media access control, data link layer, and physical layer, as opposed to the, if you're looking at IP and UDP over IP and all of that kind of thing. Here we're talking about the physical layer, and we can do a lot of things just using the LoRa protocol and sending data. In the current lab, we're just using LoRa to be able to make our own addressing scheme with the sample program that's there and send and receive data. And it's running at this 902 to 928, and it picks channels in there and will adapt. And depending on the spread out of the way the chirp spread spectrum works, it will transmit stuff over multiple bands over 902 to 928 to try and get the signals through. And will vary the amount of data, the amount of throughput that we can get through. But we're looking at small packets of information. You're not going to be able to transmit streaming video or audio or any of that kind of thing. It's designed for um, low power use, long battery life. And so the typical applications for this kind of thing is um, I have put one of these in the different water meters in everybody's house, and I have a coin cell on each one, and I don't want to replace the batteries more than once a year. And so you would say, okay, once a month, or maybe it would, some of these are saying coin cells up to 10 years on a battery life, depending on what you do. So if I was to have one of these mostly asleep, once a month, wake up, read the water meter, and then transmit it, as long as I had some sort of receiving end within a certain distance. And it can be, depending on if I have mountain ranges around me that I could have a receiver on it, you can get 10 kilometers out of these things. If you're in an urban kind of area, and there's a bunch of buildings around, you might be limited to a few city blocks to be able to transmit this. In the building here, you can start to lose signal when you go by some of the cement walls and things. In Munich, they had 7 gateways around some of the tall buildings in downtown Munich. And anybody with a device, any of your devices could transmit and get data to the internet, basically, because there are gateways which were typically more expensive that would receive the communications and encrypted pass it through a back-end channel. One of the typical ways of doing this is a network called the Things Network, which uses the LoRaWAN technology or the protocols. And so we're using just the LoRa chips and doing our own thing in this lab, but you could hook to something like the Things Network, which has stations all over the world. And as long as your device can talk to a gateway, you can send your data. And it's got a fairly decent encryption system on it. So the gateway looks at your data and it just looks like all garbage, and it forwards it to the back end of the LoRaWAN network, and then it decodes to your application. And then you can see the actual data your device has sent and things like that. And so uh, it's being used in a number of different places. So I wanted you to at least know what LoRa was and to be able to say, hey, you've had a lab, you've communicated with LoRa. I'm in the process right now. The Things Network has been upgrading from the time they first started, and they're upgrading to version 3 of their gateways and things. So I'm in the process of trying to get the gateway in our lab to update to the new system, because they're turning it off the old system December 1st. So I'm hoping I get all of that going. Anyway, it uses, it'll be interesting, I think, when you do, because you're doing comms. Do you get see? You have Sahicha, right? Do you get her for digital comms next term, or who knows? Do you get, we don't know if it's digital comms. I can't remember when you guys get that. Yeah, you don't know the CG. Well, so they'll talk about spread spectrum and all of that kind of thing, and you can ask. But it's a nice way of in you can transmit great distances, and basically your signal's almost buried in the noise floor, but you can still recover it, and it's got a great link budget. And again, they'll talk to you a little bit more about that coming up. Um, I just wanted to highlight over at I said about the Things Network, and the Things Network posted about kind of what kind of range. Here's a LoRa world record broken, 832 kilometers using 25 milliwatts. Now they put it in a hot air balloon, so they got some good height out of it, okay? And so it's over in Europe, and I can't remember where they went and stuck it from. So it says, in the past 5 years, the world record has been broken multiple times. Last world record was 832 kilometers, 517 miles. A new world record was set. Uh, the attempt was made by founder of Lacuna Space, who was presented during the Things virtual conference. Similar to previous attempts, launching a high altitude balloon with a weather sensor. And so you see it being sent off. And how they do it. They sent it from the Netherlands, it went off to Germany, and so that kind of there's their flight path. And then you'll have all of these different stations with gateways going, I see it, all of this kind of thing, and you can get this. But it's 25 milliwatts, and it's going, 800 kilometers. Yes.
What's the limiting factor? Is it power or antenna?
Well, it's all of these kind of things. So one of the limiting things is what you're allowed, for instance, on your transmitter. And so there's, for instance, 25 milliwatts and the size of your antenna and all of this kind of thing. But on the receiving side, how big an antenna can I get, and how can I get the relatively small signal out of the noise floor, so I can have a high gain antenna, things like that on the receiving side to try and pick up this. I'll talk about some of those things coming up. And line of sight, really line of sight is so if I could put something like say in Munich, they had things up on the skyscrapers around town. If I can get some good height of it, almost I could get 10 kilometers out of the thing if we could get kind of line of sight easy with what you have right now. And then some of the project groups a couple of years ago, I think I mentioned them, they built a freezer monitoring system for the use downtown. And there are some freezers in some of the restaurants. And, one of the people in the program was a chef, and the place he worked for, they've lost tens of thousands of dollars of meat because a janitorial person accidentally knocked a plug out of the freezer when they were cleaning. And so they didn't know about it. And so they come in after a weekend, and all of a sudden they lost tons of money in this. So what they did was they took the same modules you have, and then they put them in through a freezer that is sealed and big metal box, usually that kind of thing, a walk-in freezer. And they had it so that up 3 flights of stairs, they had basically a Raspberry Pi with another LoRa receiver module on it, and then it would monitor the different freezers. They had temperature sensors like you guys used in your, like the thermistors and things, and sent the temperature. And then if anything was going out of abnormal, email the owners of the place to say, hey, something's going wrong. Also put it on the Pi display for the chefs and stuff to see it. So that was going down a few flights from there. And then they were a couple of blocks away when they were doing their monitoring and stuff, and they were still seeing the measurements from the freezer down a few flights of stairs in the restaurant. So pretty cool as far as that goes. And they put it to the LoRaWAN backend, the Things Network backend, although you don't have to use that. There's other ones. There's actually, Things Network is I'll show you some of that coming up. There's another group that kind of, I think it called it the Helium Network, incorporated Bitcoin. And so they were saying you could buy these modules for a while. The routers, I think they're all hard to get right now. And then places that had a lot of traffic, instead of this being, the whole Things Network's all free to go and use and do everything. But they were saying, okay, well, the Helium Network, I think companies could pay fractional pennies per packet of data sent and use the Helium Network. And some people bought routers for like $300 and put them in places like LA and things, and they were bringing in like $65,000 a month in fractional pennies from all of these packets going by and things. So that took off. The early people made lots of money, and no one else does, right? So anyway, but that's using LoRa technology, not the Things Network, a different network, but using LoRa. Okay, so there's a bunch of different networks that you can use on this. So one of the things that was saying, okay, we have 700 and 75, 800 and whatever. What was the current record last I saw? 800 and something. Uh, what was it? 832 kilometers. So um, one of the things you're saying, okay, well, this is kind of cool. We can get with the power that we had with the 25 milliwatts, we could get line of sight. We could get 800 and some odd kilometers. Well, what if we could maybe up that a little bit or improve the antennas or do something like that? Well, there are, for instance, oh, let's, okay, there's a company called Swarm, and it takes LoRa to the sky. And satellite company has adopted IoT. Now, these guys did things a little wrong to begin with, and so it's talking about that. So those are these cool little units, swarm satellites about the size of a sandwich, has everything it needs to relay low power signals from remote IoT networks. And so they were sending up satellites into space, charging you about $1 a packet to be able to send, and they're tiny, tiny. In fact, they were so tiny, they launched their satellite but didn't check with the FCC, and the FCC was going, hey, it was illegal because it's so small they're having a hard time tracking it, so they fined them $900,000 because they didn't check with them about launching it first and things like that. So, but since then they've got the actual commercial stuff going. So it's taking a LoRa module and using that same kind of technology, sticking it up, and then if you have a device like you have, you could connect to their satellites and then communicate packages. Now they want $1 a piece. Look, Lacuna, the ones that was mentioned here, these guys, it said, hey, the guy that did this was Lacuna Space. They have satellites as well. And so there's a bunch of different companies that are saying, hey, you could do satellite things. Now, the one I thought was interesting was the open source FossaSat-1. These are, I think they were Italian college or university students, and they set up a satellite, and it's um, very first satellite built entirely with open hardware was put into operations a couple of years ago now. And this is a picture of it, and it's kind of 5 centimeters on a square, and it's got a tape measure for an antenna. And they looked for a bunch of different antennas, ways of unfolding antennas and finding this kind of stuff. And it's really hard to get the actual tape measure type steel that wraps up and folds out other than in a tape measure. And so they ended up just using a tape measure. Now, this satellite so happened to be, it's in space right now, and FossaSat-1, and somehow when it deployed, the stupid antenna didn't quite unfold properly, and so it is up there and it is transmitting. You need bigger antenna setup to be able to get information to and from it right now. So they are sending up a few more. In fact, the FossaSat-1 guys, they also, if you go look, they have a whole set up now where they say within 9 months, if you're a company and you want a small satellite to have private communications set up, you can buy their unit like this for about 10 grand, or you can build some of these from kind of open source, but they'll send it up on a rocket for you and get it into space for about 30 grand. And it used to be 100 times that, and then it was 10 times that, and now it's like, okay, it costs kind of the cost of a car sort of. And so but it's getting cheaper and cheaper. Now the one thing about these kind of satellites is they're low earth orbit satellites. They travel around the world about every 90 minutes or something like that, and so they'll last up there probably 3 years. They'll eventually, their orbit will decay and they'll burn up, and then you have to send up another one. Any of the ones that Musk is sending up, the tons and tons for his satellite service, they're all whizzing around, and the idea is that you can be in contact with a bunch of different ones. I think his will talk to each other and all of that kind of thing as well. they're not designed to stay up there long term. After a few years, they burn out and you got to send up more. And so there's a number of companies that are doing that kind of thing. So 5 by 5 by 5 centimeter, one of the smallest satellites ever launched. And so one of the other things is a number of these satellites. So FOSSASat-1 is at 435 megahertz. The ones you have are 902 to 928, so it's a different unit. So if you were to buy a module and you wanted to try and get a hold of FOSSASat-1 or some of the others, you have to see what frequency they're on. If you're on the European one, the 868, or it's on the 915, 902, any of that, your unit is good. If you have these 435, 438, it's a different SX1276 module and a different antenna system than we have there. And so you would have to look at that. One of the cool things about some of these different companies like Lucerna and the Swarm people and the FOSSASat-1 is because these travel around the world every 90 minutes or so, it's kind of almost anywhere in the world you could, if you knew when the satellite was coming by, you could wake up, transmit your data, and these are in the low Earth orbit, and then it would grab your information and store it, and as soon as it got to a ground station, it would relay your message back. And so that's kind of the idea. So you could, some of the commercial ones like Swarm and Lucerna and stuff, or Lucerna, show things like, for instance, put one of those modules on a container ship, put it on your container. And if it's traveling on a barge, or across the ocean, shipping and stuff, your satellite's going to see it every time it goes around the world and stuff. It's going to catch hold of, and hopefully get a transmission and then relay it to a station. So they're kind of cool ideas with this. Now, looking at kind of that, for instance, this is a place that, oops, this is a place that kind of monitors all of those different stations. And so if I look here, this is here is the FES, a flexible experimental satellite. I think it's at 433 megahertz. Stations currently showing stations currently listing. What's this guy? This guy is LacunaSat. And if you go and highlight some of the sections, this is a little foot. Some will be at 433 megahertz. Some will be at the 915. And it just kind of shows you the satellites all over the world. There's those FOSSASite guys. They now have 3, I think, satellites up. But there's different ones traveling all over the world, and you see all the different ground stations. So you can go to this site and it'll tell you when somebody has spotted one from one of the different ones. Sometimes it needs a better antenna array for able to receive the different data. But the project is based on ESP32 boards, kind of like you're using with SX1276. The only thing is, depending on the satellite you want to grab, you may need, like I say, a better antenna, or you may need to be at 433 megahertz, depending on the ones. But there's like 653 active ground stations, and it's just constantly sending information back and forth. One of the other ones that we had a project group do a few years ago, based on the LoRa chips, was to put basically the SX1276 and a little ARM chip. You can get one that's kind of in a single chip wafer, and they put it in a ski tag. And then the idea was you put one of these ground stations at the top of the mountain, and then you're covering your mountain. So if somebody's anywhere on your mountain, you should be able to get chirps from this device. And so if somebody goes out of bounds, you can triangulate where that tag is. So all of a sudden you say somebody's not there, and look at from, maybe you've got a couple of stations on each of the different mountains to triangulate where you're getting the pings from the LoRa unit every time it wakes up and sends a little ping. And because most of the time it's sleeping, and in fact they did something where if they were close with a handheld unit, when it pinged it, it could say stay active, use more battery, but give me more updates, so you get closer to finding them. Anyway, that was one of the projects that somebody did a long time ago, a few years ago. I want to just see the, I can't be on. Let's go to this one. Microsoft insists that anytime I click on a link, it opens up their IDE instead of Chrome, which I normally use for things. That's not where I want to be. Come on, this is where I want to be. But I'm looking for the Things Network console. I'll go there. Okay, so the Things Network again will, so you have your modules that do LoRa. The lab that we're doing this week, just we're just using the fact that it is a Semtech and it's doing LoRa communications, 900 megahertz, long range. You can just use that. You don't have to use anything else. You can communicate back and forth. And there's a number of examples in the Arduino interface for all of that. You can also utilize the Things Network, and they have, again, what they call gateways. And so typically these have been fairly expensive. You can use a Raspberry Pi with some interfaces. It's probably the radios to make a gateway, to make a Things Network compliant gateway is probably about 150 bucks. You plug it into a Raspberry Pi and it can be an official gateway. You can take one of your Heltec boards that you have and turn it into a gateway. Will work on the Things Network. It's not known as a fully compliant network. The difference being that you can transmit or you can receive stuff on a single frequency at one time. And some of the ones that are in the gateways handle multiple channels at one time. So they can get multiple, because your device will randomly pick a different channel in the 902 to 928 frequency to be able to go and transmit, and it has a certain bandwidth. And depending on how well the transmission went, it will adjust that to try and get the most throughput through. And so, so you could be transmitting at 902, then you might be going at 915. And so, if I was a receiver, I need to be able to receive across that spectrum. And if you use your Heltec chip as a gateway, then you have to pick a frequency and say, I'll listen at 915. And then you'll only hear stuff at 915. Whereas an actual gateway can hear it across the spectrum. Okay, so that's kind of the difference. But you typically, hopefully somebody's already set these up, or if you have one for quite a wide area, and what that will do is allow you to interface between your 900 megahertz system and to go into the internet on the back end. And again, so a gateway will take the information it receives from you, encrypt it, and send it to an application. And so an application will have, let's say, temperature sensors. You can have multiple different applications, And you don't even have to own a gateway as long as you're close to a gateway that is on the Things network. If you talk to the Things network, the gateway will grab your data, doesn't understand it, it's all encrypted, forwarded it to the back end, and then there are servers on the Things network around the world, and then it will eventually get to your application where you have your decryption keys, and then it will spit out the data there. And then there's some interfaces, so you could display it on, a Raspberry Pi on a screen, in a room with information that you're after from your different sensors and things like that. Like the um, guys doing the chefs looking after all the freezers and stuff. They just had a screen up in the kitchen and it told them what the current going on of the all the different freezers that were in that establishment. And so you have this common front end. And so you can use that kind of thing with there. And so again, the gateways, if you want to use this, you need at least to be in close proximity to at least one. Um, if we had a few of them, for instance, in downtown Victoria on a couple of the tall buildings, you'd probably need, one every 10 kilometers kind of thing. And so it's, attached to the internet. So that's the Things network, and we'll have a look. I have had a lab where you guys have used the Things network, and it just depends on how my gateway is fighting me on upgrading to the new version. And so if we get it up and going, then we can use one of those. I'll just see if I go back to it. See if it lets me do it. Shuts down in December 1st, I think. Permanently shut down December 1st. So I have a bunch of different devices. Let me just see what's there. You said 266 temperature sensors. So in here, for instance, on the old system, I have something called ESP8266 temperature sensors. And so I have 8 devices under that application. So you could have devices like it could say, I have an application for tracking pizza drivers, and every pizza driver has one of these modules in their car and just transmits it. And then so that could be your application, and then all your devices could be all the different pizza drivers. And then so you could track where the cars are going and put real-time updates on the routes and stuff, as long as there was enough gateways in town, for instance. This guy here is a little ARM blue pill board. It's like a $2 ARM device with an SX1276 device, and so that last time it saw it was about a month ago, and that's just sitting in my office. And again, the gateway is being upgraded to the new version, and so hopefully it will be back up and talking. And it would just every about 15 minutes just send temperature, humidity, light, and just chart it up. And so hopefully we'll get it up and going and show you that part. For this week's lab, we are looking at, where is it? For this week's lab, we are just looking at getting the ESP32 dev boards. So you search ESP32 Arduino, download the setup, and once you have that, then you go into libraries and install the Heltec dev boards library, which will put all the example programs in it. And then we open up the boards. The sample that you're going to look at is LoRa multiple communication. And so if you highlight where it is on here, you'll see exactly where it is. If you don't see this, it's because you've downloaded the board support package using the JSON file, but you haven't included the extra libraries that it says. So once the board's downloaded, you go and install this Heltech, and that'll give you the proper examples. And then the examples, um, uh, it already does stuff to go and transmit and receive. I just need you to update the code so that you're transmitting to somebody else. And then the other thing that it does that I've asked you to do is use the OLED. Now, if you look at Heltech LoRa, this code doesn't have, it has what is needed to make the OLED work. It's not specifically writing to the OLED. There are some sample programs that are there under the Heltech that use commands and make the OLED work. And so I'm expecting you to be able to go and look at one of the examples and see what you have to do and call to be able to put data on the OLED. And so, like I say, it's got the things that you need already in this file. You just have to call the right functions to be able to make it display. So I'm wanting you to put your name on the top line of the OLED and put whatever receive packets come in on the line below. And every 1 minute, send a transmit message to somebody else in the class. So you have your address and you need to send it to somebody else and they'll send over to you. Okay. And so one other thing I mentioned, if you were doing something with the OLED, I had a couple of systems where I just had in large fonts and just kept my temperature of the room, for instance, just on the screen. The OLEDs can give you burn-in, and so if you do it for a long time and then you turn it off and use another application, you can see a little faint ghosting of it. It won't happen right away, but if you left it for months, you can get a burn-in. So if you're doing something with an OLED screen, don't keep the same message on all the time. It is good to change something or have something scroll by or things like that. Like I say, for this lab and things, it's all great. If you were to keep your name on the screen and have it plugged in for months on end, you'll find that then if you go to use it for something else, you'll see a faint image of your name with the OLED kind of screen burn in. So you would want to move things around on the screen or refresh, or what I often see, like the satellite network I showed you, the Tiny GS, they have a version of their ground station to be able to get satellite reception. On the Heltech display, it'll work and it'll do the OLED, and it keeps flashing up new screens, showing you new information, keeps drawing it, and that will prevent burn-in and things as well. Okay, I'm going to leave it there. Hopefully we'll have a good week, and I'm hoping is not too onerous. It's just read the directions and look at the samples, and it should be fine.